Okay, everybody, I am going to go over a few circle relationships that I think will help you with the homework that your problems that you're working on. You don't have this in your binder, so just follow along with the logic here. We're going to have three situations. This is the first case where we have two chords that are created by intersecting lines inside of a circle, okay? And we've done this before. We call them bow ties in terms of angles. And the key component here to pay attention to is that if you draw these two little lines, the chords in, right, what we find is that this angle is congruent to this angle because they both intersect the same arc, right? So we know that these are what they call inscribed arcs. And we could say that this angle here, right, inscribes this arc, and so does this angle. And so because of this, we have that similarity, and then we have the really obvious similarity of vertical angles. And once we have 2 out of 3, we know that this triangle is similar to this one. So this one's pretty easy. We can now say, what I can think about is this is kind of like a mirror, right? We could think about this as mirror similarity. So we can now put a proportion together. We could say that x is to 3 as 5 is to 2. This is to this as this is to this. We equally as good could have done x is to 5 as 3 is to 2. I could have said that this is to this as this is to this. And notice all I'm really doing is swapping the order of these, right? And I can do that since they're cross multiplication, cross products are equal, it doesn't matter, right? Either proportion will give me the correct answer. I'm going to get 2x is equal to 15, x is 15 halves, or 7.5 if you're going to do a decimal, okay? So that one's pretty easy, simple to see. All right, we're going to do case 2 here. And to start, I'm going to go ahead and draw in these two lines that they're suggesting based over here on the right. I might be tempted to go over here the way I did here, but I don't have any information over on the left. What I do see is I have all this information on the right. So I'm going to start looking for potential congruencies there. And what I do notice is that both of these angles here inscribe this arc, okay? So what I'm going to do is I'm going to mark these two as congruent. This angle is congruent to that angle, all right? Notice that this x is referring to this side length, all right? And to make it a little bit easier to see, I mean, I'm looking for two triangles that overlap each other here, obviously, but that are congruent to each other, all right? I do have congruency here that I could use, but I don't have enough information. I've just got an 8 and an x. I'm going to need another dimension. So that means I'm going to have to go over all the way over here. So I think what I'm going to do is outline for myself the two triangles that I'm kind of seeing in this process. So here's one, right? And if this is one, if I end up treating this angle here as what we would say it's an included angle, right? It's included in this triangle, and it's also included in, let's call this the blue triangle, okay? Go across here, okay. Trying not to obliterate my yellow one, and we'll call this my blue triangle, all right? So there's the overlapping, and so just making sure I can see my yellow. There you go. So I've got the two overlapping triangles. And so what I have is, I could say this is the long side, right? I could say that I've got long side is to long side, or I could even say, I kind of like this idea here. I'm going to say that this 7 is, so the side that just touches this once, right? On the little triangle is 7. So I'm going to use this. This is the trickiest part, okay? So on the little yellow triangle, I'm going to get 7. is, see here, 7 is to, let's just say on the little triangle, 7 is to 9. Okay, so I'm going to say, I'm working with the little yellow triangle here. Okay, I'm going to say that on the yellow triangle, okay, I'm going to say the big side is to this smallest side. The biggest side is to the smallest side. Biggest side is 9 plus x is to the smallest side. This is my yellow, okay? As, looking at the blue triangle, okay, the biggest side is 15 is to the little side. Well, that would be 9, okay? So that's one way to set up this proportion, all right? You just have to be careful. If you notice, I'm doing some labeling. On the yellow triangle, my biggest side is this 9 plus x, and then the smallest side is 7. The biggest side on the blue triangle is 15, 8 plus 7, and the smallest side is 9. So here I'm just going to do my cross multiplication. Okay, solve for x. I'm going to get 9x is equal to 24, and then I'm going to get x is equal to 24 ninths. That's kind of nice to put that into a mixed fraction. I'm going to get 2 2/3. If they were using centimeters, because they gave us in centimeters, that's going to be what x is. And then I always take a look at my answer, say, does that look like it makes some sense? Well, first of all, the yellow triangle's smaller, so x plus 9 should be smaller than 15, and it is. 2 1/3, I'm going to get 11 2/3, okay? So that's going to get me going on that one. Let's go to case 3. Okay, case 3 is actually a lot more difficult to understand how we get where we're at than the other one. I'm going to do my best to kind of give you a little bit of a way of trying to remember this. So here are the two lines that they ask us, they suggest that we draw in, okay? Way back in chapter 6, we did a couple of investigations, okay? And what we found is that this angle here is going to actually be the equivalent of this angle here, all right? What that has to do, I think the best way that I can think of to think about that is, if you notice, take a look at up here where we see C. If I were to drag this point closer and closer to D, I think what we would find is, or basically what I would end up having is a situation, I would get a drawing that would look like this, okay? And if you notice in this one, I did have this angle was congruent to this angle, all right? This one's going to end up disappearing, and I'm going to end up with this congruency. It turns out this is actually fairly difficult to prove. On this one, I'm not going to run through the proof, but the point of it is that when I have this diagram, if I have one secant going through the circle and a tangent, this relationship here, this angle, will be congruent to this angle. So if you know that, and you're keeping also in mind that I have an included angle here, right? Then I've got angle similarity, right? At this point, I could mark the third angle if I wanted to. Here it's going to be, but I'm going to end up with too many markings, so I'm not going to do that right away. What I'm going to do is do what I did last time. I'm going to trace out my triangles. Okay, so I have a little triangle here. Okay, this is my little yellow triangle, okay? And then I've got a much bigger triangle. I'm going to use a wholly different color here. I'm going to use, this is the big triangle, okay? around, okay? And what we're trying to find here is our x, okay? So x is the value between the two markings. So I'm actually going to take another look at this and say, well, that's 11. So one relationship I know is that x is going to be to 11. I'm going to go back. So I have a red ratio here. I'm going to say x is to 11, x is to 11 as, and then I'm going to use a yellow ratio here, okay? This will be my yellow. Let's find what would be equivalent to x. Well, notice x is my longest side, or my shortest side on the red. So now I need the shortest side on the yellow. That's 4. What's 11 is my longest side on the red. What's my longest side on the yellow? And I get x, okay? So this is where I'm going to just do cross multiplying, and I'm going to solve. Now I get an x squared. X times x, I'm cross multiplying, is equal to 44. So x is actually just the square root of 44, or 2 root 11 if we want to be exact, right? And again, if I were to break that out, I don't have a calculator, but root 11, what would that be? Somewhere between 3, a little over 3, less than 4. So maybe, so we're going to say it should be around, somewhere around 7. And that looks about right if you look at the proportions, right? So just making sure that, you take a quick look at what you've done and make sure that you test it for reasonableness. If I had a number here that was bigger than 11, obviously something would have been wrong. So this should get you going on the problems in the homework, all right?